Good morning, everyone. Any questions? Any questions? Well, you guys put your questions out if you have them. Let's see what we've seen, what type of integration we've seen so far. So we saw integration by parts and integration by substitution. So let us a little bit integration by parts when it is, and yes, last time we saw trigonometric integral. But first, integration by parts when it is used. So integration by parts, because you're going to see a lot of techniques, and every time we talk about what we've seen. So integration by part, it's used in general. These are general rules when the integral involve those types of function, usually. Okay. A polynomial in x or a power of x multiplied by something, like multiplied by a trig function, sine, cosine, etc. Inverse trigonometric, sine inverse, cosine inverse, tangent inverse, and so on and so forth. Exponential function, or logarithm. So this is a general guideline about the integration by part. So integration by parts is used when the integral involves a power of x times trig, sine, cosine, inverse trig, sine inverse, cosine inverse, exponential, e to the x, e to the 4x, or the logarithmic function. So that's where usually we use the integration by parts, the general guideline. So I'm going to give you a bunch of functions, and I'm going to ask you the following question. Is this substitution or by parts? So substitution or by parts. We're not going to solve them. They are relatively easy, but just an idea. So suppose I give you integral of x Okay, I want quick answer. By part substitution.
By parts.
Agree, disagree?
Agreed. I'll say substitution.
Substitution.
Wait,
because
substitution easier. Never mind.
Right, absolutely substitution.
Variables are 1 degree apart.
Which make it what?
U equals x squared.
Right, this will make it immediately. The derivative of the inside is straight outside.
And
So
then du over 2 equals x.
Exactly, absolutely substitution. There is no by part in the picture. You try by parts, it's not going to work for you. However, if I put this one, I changed a little bit. Substitution or by parts? Quickly, I don't want to spend a lot of time on that. I want quick answers.
Parts.
This one is by parts because there is no inside. I mean, the inside is x. So derivative is x. Nothing is going to get me. That's by parts. And by parts, how many times? That's by parts twice. The first one will reduce the degree of x to x, cosine x. The second one will give me the picture I want. Okay, somewhere along the same line. It's not hard, but just help you focus. Parts or substitution quickly.
Substitution.
Substitution.
Substitution, because
X squared minus 3, that would be u. Then du would be x 2x.
We're done. Substitution or by part?
Wait, B is by part because you can't put the du inside of the sign, right?
Which one? B?
Yeah,
Yes,
B.
absolutely by parts. And twice. You know why twice? Okay, D. D, by part or substitution? D, I can't hear anyone.
Would that be parts?
Parts. What are the parts?
U would be x, and then dv ln of x.
dv is what?
Ln of x squared dx.
And what's the u?
X.
Uh-oh.
1 over x.
1 over x. Why? When you the leftover. If I put u to be x, it will not have the form u dv. If I put u to be x, this will not have the form u dv. You want u dv, you're going to have dv over u if you do that. I have no formula under the sun for that. Okay, it has to have to form u dv, this product. So I've tried this. Okay. If I do that, what's the v? Sorry. If dv is ln of x squared, the v is going to be the antiderivative. What's the antiderivative of that? Is it easy or hard?
That's too hard.
That's hard. It's not impossible. It's absolutely not a piece of cake. I want you to think a little bit more.
Would it be the other way around? U would be
Okay,
ln of
let's
x
see.
squared.
All right, I am. So you want u to be the ln of x squared. dv is 1 over x dx. So this is going to give you du 2 times ln of x times the chain rule 1 over x. And this is going to give you v, the antiderivative, minus 1. Sorry. Antiderivative of 1 over x, which is ln of x. Okay, I'm following you till you figure it out. So it's uv. uv. u v minus v du. Are we improving?
Doesn't seem like it.
Okay. Anybody else? Are you going to change your mind? All of you.
Substitution.
Absolutely. Why substitution?
Because
What?
if you do ln of x, then your du would be 1 over x.
Right. Substitution, fairly straightforward. If you put u to be ln of x, derivative 1 over x dx. Problem solved. U squared du. Okay, so it's techniques we have really to think about. So definitely substitution. What tells me substitution? Because the derivative of ln is 1 over x. Okay, my last question is this one. E, or whatever this is, A, B, C, D, whatever, if I give you ln of x over x squared. So I'm changing a little bit, but the whole problem changed, of course. What about this one?
That would still be by parts because you can't put the du inside of the ln.
Yeah, that's absolutely by parts. What are the parts? But put u equal ln, the derivative is 1 over x. I still have a mess to deal with. What are the parts? When I say what are the parts, I mean what's the u and what's the dv.
U is the natural log of x.
We don't have any other choice yet. And the dv? Left over. What's going to be left over?
1 over x squared.
That's what we're going to left over. 1 over x squared dx. The rest, you should finish it. Okay, so the second part usually is what I said, the leftover, whatever left. If you put u to be ln, okay, what's left? What is ln? This is going to be written ln of x times 1 over x squared dx. That's really what I mean by the leftover. It has to be a product, u dv, for the integration by part. If you pick this to be your u, 1 over x squared dx will have to be your dv. Okay. So this is just a quick recall for substitution versus by parts. And every time, usually, when we introduce new integration technique, we're going to start mix and match. So you can decide what method you use in each scenario. Right, so today we're starting the trigonometric integral. I did a little bit last time, but today I'm going to use your questions to clarify it fully. So trigonometric integral. Okay. And as I said, those are integral of the form sine nx. It means sine is raised to a power. The cosine to a power dx. This is the type of integral we are interested in. Okay. And how to integrate them is going to be split into two parts depending on the power. So the first part is case 1, n or m is odd. One of the power is odd. Okay. And the idea would be is split the odd power, split the term with the odd power, and through the problem we will of course review how to split them, and use substitution, u equal sine or u equal cosine depending on the problem, and the problem would tell you what to pick. So split the term with the odd power and use substitution, u equal sine, u equal to cosine, and the following trig identity. Sine square plus cosine square x equal to. Okay, so we have to split the odd power and use this substitution together with this identity. So if one of them is odd, that's going to be the technique we will use. So let me do 2 problems. So I look at number 15. need to open the book. I forgot to get the book open. Number 15. All right, so this is it. Number 15, integral of. Okay, sine cube, cosine square. Okay. All right, so now which one is odd? First, we look at it. One of them is odd. This is the odd power. 3 is odd, of course, 2 is even. We take the term with the odd power, and this is the one we are going to split. So this is going to be split like this. The integral of, I'm going to rewrite it, cosine square times. The odd power will be split into an even power and the term sine x dx. That's how we split it. So that's the even, and sine x dx would remain. And now we're going to make our substitution. We're going to pick the u. Now, the way we pick the u is so that the term that we cut off has to be the du. That's really the easy way to think about it. The term we cut off will have to be the du. So it means I want my u to be the cosine. Okay, that's the one I want to be, du or minus du. So du would be minus the sine. But now to be able to make a substitution.
Wait, so the u is just the derivative of whatever we cut off?
Or antiderivative, basically. But it doesn't matter because it's a sine and cosine. Because this is going to be the du. So the u has to be antiderivative, should be the cosine. Got it?
And then you're not worrying about the negative because that's just a constant.
Exactly. We never worry about constant because those will go out. Okay, so I'm gonna remove the u. I put the u just to give you a guideline. That have to be the derivative. But now, since it's a substitution, everything has to be in terms of u. It means that cosine square is acceptable. It's sine square I can't keep. This has to be substituted in terms of u. So I will do one more step and then we'll do the substitution. I don't want sine anymore, so this has to be in terms of cosine. And this term is safe because it's going to be picked up by that. So this will be safe in terms of du. This has to be 1 minus cosine square. And now we are absolutely ready. That's u squared, 1 minus u squared, and this is minus du. Because it's a constant, we don't worry about it. Yeah. Yes, so this is a constant, it will go out, and I will have u squared minus u to the power 4 du. Okay, and now it's simple. I will have minus 1/3 u to the power 3 minus 1/5 u to the power 5. And that would give me minus 1/3 cosine cube x minus it's a plus 1/5 cosine 5x plus c, end of the problem.
I have a question.
Of course, go ahead.
You got the negative du from the regular du, but that's just the opposite of it, right?
Because the derivative of cosine is minus sine. That's your question.
I'm just wondering how you got the negative du right there.
Okay, because it's a substitution, right? So everything has to be substituted in terms of u and du. So are you with me up to here?
Yes.
Okay, now go down a step. Cosine squared become u squared.
Wait, real quick.
1 minus cosine squared will be 1 minus u squared. But what about sine x dx? It's not du. Sine x dx is minus du.
Is the sine squared becoming the 1 minus cosine squared?
Yes.
How?
Okay. Let me go take you back here. This one. That's crucial. We're going to be using it a lot. This is the main trig identity that relates to sine and cosine.
Oh, yeah, that etchy kind of looks familiar.
It's going to be crucial. So this gives me that the cosine square is 1 minus the sine square, and the sine square is 1 minus the cosine square. Is that clear? Okay, I'm going to use this identity a lot in this section and in another section, and you guys will use it all the time. Okay, does that make sense? All right, so now I go back to my problem, and then I substitute verbatim. Verbatim. So cosine square, I kept it. Sine square is 1 minus cosine square, and sine x. Now in terms of u is cosine. That's u square. Now 1 minus cosine square. But u is cosine. So cosine square is cosine x to the power 2, which is my u square. And then sine x has become the my du. Okay, before I move on, please ask any questions. I'm trying to read the ones you're putting on chat. Try to answer them. Any question before I move on?
I have one more question.
Yes.
So at the beginning of the problem, you'll always split the odd power so that there's always one single one left out.
Absolutely correct.
Okay.
Absolutely correct. I always want to cut off the sine x dx. And I will cut it off only from the odd term. And I will explain why in a second later on, why if I cut it off from, why I need the odd term. Otherwise it's going to be very hard. And I will explain where the difficulty is.
If it was, let's just say it was sine 5x times cosine squared x. If you split the 5x to 4 to sine 4x times sine x, what would you do about making the sine 4x into 1 minus cosine? Like making it into that different.
I hope, yeah, that's a very common, I mean, that's a very typical problem. Let me see if 18 addressed this or 20. No, neither one addressed this, so I'm going to address your problem, okay? And then I will look up 18 or 20, I want to do both. So I'm going to take exactly your problem. Okay, so example. I will follow you. I think you gave me cosine 5x. Sine squared x, right? Okay, we're going to do that because that's a very standard problem. Okay, so and now I look. Which one is odd? This one. Okay, I split the odd. So it's going to give me. I rewrite it this way, so, and I split this one. Cosine for x, cosine x dx. Okay, we're going to split that. Now, I want to pick my u. What do you think I'm going to pick my u to be? Please, all of you be part of it. What do you think I'm going to pick my u to be?
Sine x.
Sine x, because I want this to be the du. So I'm going to pick u to be the sine x. Du is the cosine x dx. Now everything has to be in terms of sine. So now I look at it. Sine squared is safe because it's u squared. What about cosine 4? Is it safe? All right, what's cosine for x? It's cosine squared x raised to the power 2 times cosine x dx. I didn't substitute yet. I'm not ready. I want everything in terms of sine. But do you see why I did that? What's cosine square?
1 minus sine squared.
Okay. Did you see how we solve this problem? As long as I have even, I am safe. Because if I have 6x is cosine squared to the power 3, then I am safe. 8x here, if I had 8, this would be cosine squared to the power 4, and I am safe. Now I am ready to substitute. Okay, the sine square become u square. 1 minus u square to the power 2 cosine x dx. That's where I am picking up my g. All right. It's a very good question. Equal. Now it's u squared times. The only way I can do this is by distributing. So I will have 1 plus u to the power 4 minus 2u squared du. And this would leave me 2. U squared plus u6 minus 2 u squared times u squared, u to the power 4 du. So finally, I will get 1 over 3 u to the power 3 plus 1 over 7 u to the 7 minus 2/5 u to the power 5 plus c. So I will get a third. My u was the sine cube of x minus 2/5 sine 5x plus c. Okay, and that will be the solution. So I will so this technique will apply. So for example, if I give you, suppose I'm not going to do this, suppose I give you integral of cosine 7x dx. Do you think we can do this problem? How do you think I can do that? Anybody?
If we were to do that, wouldn't everything be to like du? Because there is no, we wouldn't have a u in this problem.
Oh, we have to have a u. Follow the algorithm verbatim. I don't have some, but I don't think it's a problem. Do we have a power? That's an odd power. So we're gonna split it into cosine 6 cosine x dx. It will still apply. What do you think I'm gonna put my u to be? So the algorithm will apply verbatim.
Cosine x.
No.
Sine x,
Sine, why?
because the derivative of that is cosine.
Right. The term we cut off has to be the du. So u has to be the sine. The du will be the cosine. The term we cut off, the single power of sine or cosine that we're cutting off has to be your du. So the single power that you cut off is not, I'm trying to focus it a little bit. It's the single power will have to be my u or du. And now you tell me, it's not easy. But now what do you think I'm going to do? Quickly. How I'm going to convert cosine 6x in terms of sine and cosine. How can I write cosine 6x? I know it's Monday. Wake up, guys.
1
Would you
minus
do-
sine squared to the third.
Right. Cosine 6x is cosine squared x to the power 3. So it's going to give me 1 minus. It's tedious, but it's not going to be hard. I will not finish it because I think it's shouldn't be hard at this stage. 1 minus u squared to the power 3 times the du. Okay, now you tell me, but it's to the power 3, you just have to distribute this term. You don't have any other choice but distributing. There is no derivative of it outside. The only way I can do that is distribute and then proceed. Okay. So even if I don't have sign, as long as there is a odd power, the algorithm is actually clear-cut. Okay, so now we're gonna do either 18 or 20. Let me see. Pretty much the same, so I will do number 18. So we have the following integral. Sine cube of theta cosine minus u theta d theta. Okay. Or if you want, you can keep it like this, or that's basically that. All right, ideas.
Should we split sine
Go ahead.
cube theta?
Just one of you, just talk.
Split sine and then change cosine squared to 1 minus sine squared.
I'm gonna split sine first, and then you decide. Okay, split. Don't do all of it at once because you have to decide what's the u first. So I'm gonna split the sine because that's the odd power. Okay. What do you think it's gonna be the u? Remember the term you cut off. The term was a single power.
Wouldn't it be cosine delta or theta?
Right, u is going to be the cosine of theta. So before you start, you have to decide what's the u. And the du will be minus the sine of theta d theta. And now as is what's going to be. Which one we have to split now? Sorry, which one we have to substitute? This is taken care of. This is taken care of. It's the sine square that has to be written in terms of the cosine. So my last step is going to be, this has to be substituted. Everything else is in terms of cosine basically, or it's the du, so I don't have to worry about it. And now we do the substitution. 1 minus u squared over u squared. This is minus the du. And now I take the minus out, and then I split 1 over u squared minus u squared over u squared, which is 1 du. Okay, that's, I can split the numerator, giving me 1 over u squared minus 1. So finally, I will have minus. The derivative of 1 over u squared, remember, 1 over u squared is u to the minus 2 du. So it's 1 over minus 2 plus 1. So it's going to be minus 1 over u, because this is 1 over minus 2 plus 1, u to the minus 2 plus 1. It means minus 1 over u. Minus antiderivative of 1 is u. So minus minus, I distribute 1 over u. My u was the cosine theta. Minus minus, it's a plus. The cosine theta plus. Okay, without those techniques, it's so almost impossible to get there.
I have a question.
Yes, please go ahead.
Where'd you get the negative from in the du? I thought the du was just the sine.
What's your u?
Theta.
What's your u?
Oh, okay. It's cosine theta.
Yeah,
Or yeah, that was
to be cosine. Okay, this piece should be the du or the minus du. It depends on your choice. But at least it guides you what your u has to be. The term you cut off has to contain the du in it. All right.
all right. Thank you.
Sure. Very good. So number 20, you guys do it for tomorrow. I will not do it. You have to do it on your own. And if you really struggle with it, let me know. So we took the case where one is odd or both odd, it will work. So even if I have something like that, if both of them are odd, so this is 5 and 3, it's the same approach, but then you will have a choice which one to split. And usually you have to split in a smart way. Okay, so you will have a choice which one to split. So if both are odd, it's the same technique. You split one of them and you proceed. So which one you want to split in this scenario?
Cosine to the power of 5.
Okay, if I split the cosine, so suppose I split the cosine, then what's going to be my u?
Sine.
It has to be sine because the term to cut off, it has to be the sine. And then the du would be the cosine, d theta. And this would give me. Which one do you think is easier to split?
Fine.
Sine. Why?
Because it just
No, you
changed.
don't have to split both of them. I have a question that one of classmates asked me if both are odd, do you split both of them? No, you split one of them. You split one of them. Here it will be easier. This will work, no question asked. Here it will be easier to split the sine because it's so easier to split the sine. Easier only.
Sine squared, and you can easily replace that.
Right. Easier to split the sine. Okay, because if you split the sine and then you will have cosine 5 theta, sine squared theta, sine theta, d theta. And then you won't have to deal with cosine 4. Then you can put u to be cosine, the du will be the sine, and this would give you u to the power 5. That's how safe you are. 1 minus u squared, and then this will give me the du, which will be much easier. Okay, so if both are odd, you pick one of them and you split. You do not split both. You split one of them if both are odd. Okay. All right, so the question is, what happens if both are even? Both are even, and why our technique failed in a way, or it's more complicated. So the case where, so case 2, integral of the 4 cosine nx, where n and m are even, and there is an and in here. It means both of them even, not one of them. Both of them are even. Okay, all right. So how do we do that in this case? Today I'll show you how to do it, and tomorrow I tell you why our previous technique failed, because you have to know why it's gonna fail. All right, those we have to use trig identities. Okay. And we're gonna use something called the half angle formula. So we use the following identity. Okay. Some things that you probably have seen when you studied the trigonometric class, that usually those formulas that never stays in our mind unless we use them. We're going to use the following. sine square x 1 minus is equal to that. So that's the trig identity. And cosine square x equal 1 plus. So it just doubled it. So from here to here, the angle is multiplied by 2. From here to here, the angle is halved. And they are both cosine. And we call those half angle formula. Okay. The benefit of those identity is that it substitutes its square power with a 1 power. So instead of dealing with sine square, I will be dealing with the cosine by itself. And that's really going to be the benefit of that. So let me do one problem, actually as simple as, let us try to find the antiderivative of sine square x dx. Despite its simplicity, we actually don't have the tools to do it so far. And now the idea is how to find the antiderivative of sine square. There is no odd power in the picture here because I only have one even power. So we're going to use the half angle formula. Okay, let's see how we use it. It's going to be equal to the integral of 1 minus cosine 2x divided by 2 dx. Okay, I use it verbatim. 1/2 is a constant. A half could be pulled out. And then I will be left with 1 minus cosine 2x dx. Again, the benefit is I don't have a square to deal anymore. That's the benefit of the half angle formula. It gets rid of this power of the sine. So now I have to evaluate each one of them. 1, antiderivative of 1 is x minus antiderivative of cosine 2x. So I have an inside function here. So I'm going to a little bit isolate it because it's inside function. I have to deal with that. It's not the sine because there is an inside. So I make this little substitution. So I'm isolating. U equal 2x, du is 2 dx, and this would give me the integral of cosine u. Instead of dx, I have a half du. It means a half antiderivative of cosine is the sine of u. It means a half sine 2x. So antiderivative of cosine 2x is not the sine of 2x because of the chain rule. It's a half the sine of 2x plus my constants. And now that's the end of the problem. So we can distribute the half if you want. Doesn't really matter. You don't have to at all. Plus C. Okay, so whenever I have even power, only even, there is no odd in the picture. And then we have to use the half angle formula. Let me do one more along the same line. Suppose now I have, what do I have? Suppose I have, I don't know, sine 4. Let me make it a little bit harder. 2 theta d theta. Okay. So again, I look at it. I only have even power. So I use the half angle formula. But how can I use it? The half angle formula involves the square. If I had a 4 power, how am I going to use the half angle formula?
Would it be sine?
It'd be sine squared of 2 theta multiplied by sine squared of 2 theta, or just squared.
Absolutely correct. It's still even. So I can rewrite it like that. Now I use the half angle formula at this stage. So it's going to be equal to. Okay, what does the half angle formula tells me here? I'm going to rewrite the basic one, and then you guys tell me what is true. So the basic one, the one I gave you is that the sine square is 1 minus cosine 2x over 2. If I apply it here, what this would give me? Please, everyone, because how should I apply it? What should I write here? So instead of sine square, I'm gonna substitute it, use the half angle. How would this become?
Would it be
Would
1
we-
minus
Go ahead.
4x
Tell me what to write. 1
minus the cosine of 4x?
minus the cosine exactly of 4 theta.
Oh,
Of
right.
whatever the angle here, this is twice that angle. To be very careful how you apply it. Whatever this is here, it's divided by 2. Okay? Whatever the angle here, this is twice that much, equal. All right, now we have to distribute, see what we're gonna get. So if I distribute, this is gonna become a 4, and this would become, this is to the power 2. It means 1 plus cosine square for theta minus 2 cosine for theta d theta equal. Okay, 4 is constant. The 4 will go. And then I will be left with this. Equal. Very good. Now, how can I finish? I go through each term and ask myself easy or hard. So 1, do we know what's the antiderivative of 1?
X.
Yes. Cosine square theta. Do we know what is antiderivative? Do we have the tool to find it?
You have to isolate it, right?
What do you, yeah, and do what? How can I isolate it? Okay, I will isolate it, but then how shall I do it? What kind of power does this have?
Use the half angle formula again.
Exactly. I have to use the half angle formula again. I have to use the half angle formula again because it's a square power. What about this one? Is this easy or hard?
It's easy.
That's it, relatively easy because I have 4 theta. So this is still, I have to use the half angle formula. You can isolate it, use the half angle formula again by itself, or you actually can keep it a little bit because it doesn't require really substitution, it's the half angle. So this is gonna become the following mass. So we're gonna use it again. 1, the cosine is the plus cosine of 8 theta minus 2 cosine for theta, the whole thing d theta. Now I will wrap up everything. So it's going to be 1/4 times the integral of 1 plus. Okay, this one I can split into a half plus a half cosine 8 theta. So kind of messy, but it's not hard. It's not difficult. So it's going to give me 1/4 the following integral. 1 plus a half. This will give me the 3/2.
I have a question.
I'm listening.
How'd you get the 2 1/2s? I thought you can only take out 1/2 from 1 plus cosine 8 theta over 2.
Wait. Where are you? Here?
You took the next one when you took out 2 1 plus 1
This-
over
This one coming from this one. Okay. Where is this coming from?
I thought it'd be 1/2 times cosine of 8 theta.
Why times? What's this?
Oh, it's plus. Oh, yeah.
Yeah.
Okay.
Got it?
Yeah, but I'm just wondering still, how'd you get the 1/2s?
Here,
Yes, how'd you
I
get both?
split the numerator. You know, it's I just split the numerator. So I have 1 plus cosine 8 theta, the whole thing divided by 2, right?
Yeah.
Okay, this is equal to what? Split the numerator. It's 1/2 plus cosine 8 theta over 2.
Oh, okay.
Okay, because that's a numerator. I can split the numerator.
Oh, okay, I get it now.
You sure?
Yes.
Very good. So let us finalize this. Where am I? So now that we can split only because I'm splitting the numerator minus that. The 1 plus a half gave me the 3/2. A half cosine 8 theta minus 2 cosine 4 theta. D theta. And now I have to evaluate this. Okay, now it's equal to 1/4 times 3/2. The antiderivative will be 3/2 theta plus a half. This is a constant. Antiderivative of cosine 8 theta, if you use substitution, you're gonna get 1/8 sine 8 theta because I have the inside minus 2 times antiderivative of cosine 4 theta is going to be 1/4 sine 4 theta plus c. End of the problem. Okay. Look, I don't know. I'm sorry, I don't know what reading day is. Yes, we do have class on Wednesday. What's reading day? I should know. I don't.
I thought there was like 3 days that they were going to randomly give us to not have class because they took off some of the weeks from our other vacations. I thought I saw something like
No. It has nothing to do with
No.
with us. No. I honestly never heard of it. No. You know, if you had regular class face to face, today would have had a day off because the weather. Anyway, questions? All right, very good. So whenever you have even, our salvation, both even is this, have to use the half angle formula. If one is odd, one of them, then we have to split and proceed. And that will sum up this type of integral. Right. Time is up. If anybody has any questions, you guys can stay. The whole class is dismissed.